10.3 Operations with Radical Expressions. We're going to take our simplifying radicals and we're going to be able to add and subtract them. And that's about all we're going to do in Algebra 1. When you go into Algebra 2, you'll be able to multiply and divide them. But for this year, we're just going to be simplifying, adding, and subtracting. All right, so let's go to the next slide. So when you're adding or subtracting radicals, they're treated similarly like fractions. Remember, when you were adding fractions, you had to have common denominators. So if you were to add 1/2 plus 1/3, in order to do that, you would have to have the denominator or the bottom numbers be the same. And if they weren't, then you had to change them. So you had to actually go and write 1/2 and figure out what it was the common denominator between 1/2 and 1/3. Well, if you multiply the two bottoms, you found out that 6 is a common denominator, and that happens to be the lowest one. So you could change the 1/2 into 6th and the 1/3 into 6ths. All right, so this would be, what would you do to the 2 to get to 6? Well, you can multiply by 3. And whatever you do to the bottom, you must do to the top. Notice that I'm just really multiplying by 1, but it's 3 over 3, so it changes it, and that's why we use this. So that would become 3 times 1, which is 3/6. And then over here, the same thing. What did I do to the 3 to get to 6? Well, I multiplied by 2, so I would multiply the top and the bottom by 2 over 2, which again, that's 1. So we're not really changing the problem. We're just working around and moving things so that we can work with it. So then you multiply the top, 2 times 1, which is 2/6. So you have 3/6 plus 2/6, which would make 5/6. And that's how you would add fractions. What you're going to do is similar with this, except for you're not going to be finding common denominators and making them common denominators. What you'll be doing is you're going to be simplifying radicals to see if anything is a like term. So you must have the same radicand, which is going to be what's inside. Let me change color. What's inside the radical is the radicand. Okay, radicand. Sorry, that D didn't look very well. Radicand. The number inside, or the variable number combination inside the radical, is the radicand. And we're going to make sure, in order to add or subtract them, that they have the same radicand. We're only going to be working with just square roots, usually in one problem, or cube roots in another. You will never be adding or subtracting different indices. In other words, you won't have anything like square root adding together with the cube root. Okay, even though the radicands are the same, the indexes are different. This is not going to work. You can't do that as far as simplifying. So we won't be ever having those. There will always be either square roots and square roots or cube roots and cube roots, okay? So don't have to worry about that. What you'll look for is if it's simplified. Now, on this particular example, we have 2 times, and this means times because they're put together. There's no plus or minus in between, so it's multiplication. 2 times the square root of 3 plus 4 times the square root of 3, and we're going to add those two. Well, because the radicands, if you'll notice, are both square roots of 3, we can go ahead and add these by adding the coefficients. It's kind of like adding like terms. If you had 2x plus 4x, you would tell me that is 6x. That's what you're doing here. The common denominator, or not the denominator, but the common term is the square root of 3. So we would just add 2 plus 4, and that makes 6, and then square roots of 3. Just like when we added the 2x and the 4x, we did not do anything with the exponents. We don't do anything to the radical either. So it's just 6 square roots of 3. So notice that the insides doesn't change. You're only adding or subtracting the outside terms. Okay? Now, if the insides or the radicands are not the same, then you need to simplify the expression to see if you can find anything that will add together. Okay, so for example, in our problem right here, 3 times the square root of 2 minus 4 times the square root of 8. Well, square root of 2 is as simplified as you can get, but square root of 8 is not. And remember, we did the prime factorization tree, so we had 4 square roots of 8. We need to break that down. So I would break down the 8 and do prime factors. So that would be 2 and 4 and 2 and 2. And we're looking for groups of 2. That would come out and multiply to that 4. So that would become 8 square roots, and we had 1 and 2 left over. 8 square roots of 2. So then you put it together and see if it works. Well, yes, because this already had a square root of 2 as its radicand, we can put these together. So now it's workable. 3 square roots of 2, take away 8 square roots of 2 is going to give you a negative 5, because 3 minus 8 is negative 5 square roots of 2. Okay? Same with the next problem. It's negative 9 times the square root of 27x, and we're adding 2 times the square root of 48x, okay, and we need to break those down. We know that 27 and 48 are not simplified. So I'm going to go ahead and see, I guess I can write something over here so we have room. I'm going to write over here. All right, so negative 9 square root of 27x. All right, so we're going to break down the 27. That's going to be a 3 times 9, which breaks down to a 3 and a 3. And we circle our pairs, so that comes out to multiply to the 9, and then we have a 3 left over. Okay, so that would become negative 27 times the square root of 3. Now, this x is just one of them, so it can't come out as a pair. It's just one, so we just leave it inside. So if this simplifies to negative 27 times times square root of 3x. All right, so then we're going to do the same thing with a different color. 2 square roots of 48. I'll just write it right here. 48x. Okay, 48 breaks down to 2 and 24. Which breaks down to 2 and 12, which breaks down to 2 and 6, which breaks down to 2 and 3. Circle your groups of 2. That's 2 times 2 right there, which is 4. And 4 times what's out there already is 8. And that leaves a 3 and an x inside. All right, so now we have negative 27 times square root of 3x and 8 times the square root of 3x. And we're going to put those together. So negative 27 plus 8 is going to make a negative 19 square roots of 3x. Okay? And then the last example is cube roots. Okay, you still do it the same way. Notice we have the same indices. That's the cube root. And we just break down the 32 and the 108. So I'm going to put 32 up here. I'm going to break it down to 2 and 16, 2 and 8, 2 and 4, 2 and 2. And I circle my groups of 3 because we're talking about cube roots. There's one group of 3, so that comes out. And then I have 2 times 2, which is 4. So this becomes the cube root of 2 cube roots of 4. All right, let's break down the 108. So that's 2, negative 2 cube roots of 108, which breaks down to 2 and 54, 2 and 27, 3 and 9, and 3 and 3. All right, so we're looking for groups of 3. So I have 1, 2, 3 threes, Okay, so that's a 3 that comes out and multiplies to what's already out there. So that's going to be a negative 6 cube root of, and that's 2 times 2, which is 4. All right, so now we have 2 minus 6, which is negative 4, and that makes this negative 4 cube roots of 4. Okay, so it's all about simplifying. Now, some problems you're going to have where it doesn't simplify. It might simplify, but you just can't do anything else with it. For example, if I had the square root of 6 minus the square root of 8. Okay, let's just say that. Well, the 6 doesn't break down but for 2 and 3, so that doesn't change at all. It's as simple as it can go. But the 8 breaks down to 2 and 4, 2 and 2, and you circle your pairs. 2 will come out, so it's square root of 6 minus 2. This comes out, square roots of 2. Well, that is as far as it goes because these do not have the same insides. So this is as far as this expression goes, and you'll just write it just like that. But it has to be simplified in order to be finished. So when you have this kind of problem, you will write this. And even though that doesn't look like an answer to you, it is an answer because that is as simple as it can be. Okay? And I think that was the last slide. Yep. All right, so we will work on these in class. Come see me if you have any problems, and I'll see you then.